And now we're going to talk about water supply. Our unit objectives here are going to be identify the parts of a water distribution system, identify the causes of increased resistance or friction loss in water mains, identify the types of water main valves, define the terms static pressure, normal operating pressure, residual pressure, and flow pressure, identify the differences between dry barrel and wet barrel hydrants, describe the condition which reduce hydrant effectiveness, and demonstrate the assembly and connection of drafting equipment required for drafting from a static water source. Water supply. Water has always been the primary extinguishing agent for firefighting for its availability, its cheap, its effectiveness, and ease of storage and transfer. Firefighters must have a knowledge of water supply systems and how to use these systems to supply water for firefighting efforts. Water distribution systems. These systems can be public and private water supply systems, typically serve large areas with numerous individual properties. They may be city-operated utility, public water supply district, or private water company, and have several municipal water systems in Missouri have been sold to private corporations. Water distribution systems. We have surface water, such as rivers, lakes, reservoirs. Groundwater, water wells, water producing springs. Alright, our means of moving water is direct pumping. Use pumps to tank water from the primary source. Take water from the primary source to the treatment process and into the distribution system. Most direct pumping systems are found in agricultural and industrial settings. The main disadvantage is the reliance only on pumps and electricity to operate the pumps. Backup generators and duplicate pumps may be needed for reliability. Gravity systems uses a primary water source of a higher elevation than a distribution system. Gravity pressure is adequate only when the primary water source is more than 100 feet higher than the highest point in the water system. Combination systems. Most communities use a combination direct pumping and gravity system. Water is pumped from the treatment facility to elevated storage tanks. That's where you get your pressure from, is when it comes down out of these tanks into your mains. Gravity flow supplied by elevated tanks for storage and pressure. When consumption is high, the tanks supply extra water and pressure. Elevated reservoirs can ensure the water supply when other parts of the system may be inoperable. Processing and treatment facilities. They provide treatment to remove contaminants and add chlorine to kill bacteria. May add fluoride or oxygen to the system. The fire department's concern with treatment facilities is that a maintenance problem, power loss, or fire may reduce the volume of pressure available in the water supplies. A secondary potential problem for firefighters is the large quantities of chlorine which may be stored at these facilities. Some people use liquid chlorine, other cities use the gas chlorine. So whichever is in your response area, you need to check with your public works or your private water district to see what type of chlorine that they use and have on hand and where they store their tanks at. Distribution systems. The amount of pressure of water that a distribution system can deliver depends on the capacity of its pipework and the capacity and elevation of its storage tanks. A grid system, a distribution system that has circulating feed from several mains. Primary feeders, okay, are your big blue outline here, your primary feeders. These are large pipes that convey large quantities of water for distribution to smaller mains, 16 to 72 inch in diameter. Your secondary feeders, intermediate sized pipes within the loops of primary feeders that aid the connection of flow, 12 to 14 inch in diameter. Your distributors, smaller mains serving hydrants and blocks of consumers, 6 to 8 inch in diameter. Two or more primary feeders can run from the water source to high risk and industrial areas. Water mains, underground water mains may be constructed of cast or ductile iron, asbestos cement, steel, polyvinyl chloride plastic, and concrete. Okay, a water main must be the proper type for the soil condition and pressures needed. Some soil types may corrode some materials. Extra protection may be needed to prevent break in certain soil types. The interior surface of the pipe creates resistance, friction loss to water flow. Incrustations and sediments in a pipe can also assist with causing an increase of friction loss and not getting the water supply that you're looking for. Recommended size of supply line from the American Water Works Association. Residential hydrants should be supplied with 6-inch mains. Businesses and industrial districts, 8-inch with cross-connecting mains every 600 feet, and a 12-inch main should be on principal streets in long mains. Elevated storage tanks are located throughout a water system to give a constant pressure, usually steel or concrete. The higher the tank, the greater the head pressure, the elevation pressure, which forces water throughout the system. It could be on towers, on ground level, on hilltops. Typical range from 5,000 gallons to over a million gallons. Water main valves. Valves should be within the grid system, so small districts can be shut off without affecting the entire system. The water department must be able to open valves when increased flow is needed during an emergency. In the event of a main break, the valves may have to be closed to isolate areas. Isolation valves. Isolation valves. These valves are shut off water to isolate sections for maintenance or repair, replace hydrants, and make connections to the system. Valves operation should be tested by the water system operator annually. Generally located below ground and accessible through metal covers. Usually require a special wrench or water valve key to operate. The valves are fully open, friction loss increases and available water decreases. Gate valves may be indicating or non-indicating. The control valve is operated by a handle or screw mechanism which rises or lowers a plate into or out of the waterway. Butterfly valves may be indicating or non-indicating. The control valve is operated by a handheld mechanism which rotates a valve disc to open or shut the valve. Indicating valves visually show if valve is open or closed. Okay, these control valves here, or these indicating valves that we have here, the one on your left is mainly used for a fire protection system. This valve here, you can see the window will say open or shut. There's only 4 letters in there. It won't say open or close, it just says open or shut. And then you have the post indicator valve, which is here on the right, the blue one. If it is closed, that thread will be all the way down into the valve, and if it is open, the screw or the threads will be all the way through the handle and sticking out the top. Okay, the control valves are located between public water systems and private distribution systems. It can be used for pressure reducing, pressure sustaining, pressure relief, flow control, float valves, check valves. Backflow preventers are usually required to prevent water from flowing back into the public water system so we don't get cross-contaminated. Pressure within water supply system. Pressure is the velocity of water through pipe or hose of a certain size. Pressure is the velocity of water through pipe or hose of a certain size. Oh, I just said that. Static pressure, stored potential energy available to force water through pipes or hose. Normal pressure within a system before a hydrant is open. True static pressure is rarely found in a water system. Normal operating pressure on a water system during normal use demands. Residual pressure is a pressure left in a water system at a location when water is flowing, and flow pressure, forward pressure at a discharge opening. A failure or reduction in water supply can be caused by damaged hydrants and valves and connections, broken water mains, large demand that the system cannot supply, hydrants on dead-end mains, closed valves, obstruction in mains, and pipes that are or hydrants that are frozen. Fire hydrants. Hydrants are located at intervals along water distribution systems. Hydrants are to be spaced at various distances based on required fire flow for occupancy, types of construction, the building size. Generally, hydrants shall not be spaced more than 300 feet apart in high-value districts. As water flows through piping, its movement causes friction, which reduces the pressure. Friction loss is also increased by incrustations inside the water main. Friction loss reduces the volume and pressure available from fire hydrants. Less pressure will be lost when fire hydrants are supplied from 2 or more directions. A dead-end hydrant receives water from only one direction. When a hydrant receives water from 2 or more directions, it has a circulating feed or pipe loop. Hydrant construction. The parts of the barrel, the bonnet, a foot piece are constructed from cast iron. Your internal parts, working parts, are usually made of bronze. Valve facings may be rubber, leather, or composite materials. A 3-way hydrant. These have a 5-inch outlet referred to as the pumper outlet, nozzle, or steamer connection, which is the big one on the front, and 2 outlets for 2.5-inch couplings. Dry barrel hydrants, which That's what we have in this area, or used in areas where freezing occurs. The valve holding back the water is located underground below the anticipated frost line for the area. Also here, when you open a hydrant, make sure you fully open it. Make sure you turn it all the way on, and when you turn it off, make sure you turn it all the way off. This little thing that the arrow is pointing to on the bottom, that has a drain in it, and that's what lets, when you shut the hydrant off, lets all the water drain out, and it drains out into the ground. If you do not open that hydrant fully, or if you do not close it fully, the pressure that is coming out of your hydrant is also going out those drains, and what will eventually end up happening is it'll blow all the gravel and the dirt away from the base of that hydrant, and your either hydrant's going to come out of the ground or it's going to fall over on you, and the public works guys are not going to be very happy because they'll be out there having to dig it up and replacing it. The water in the barrel drains through a small drain at the bottom of the hydrant after closing, which most of these drains actually are a little lower than this one, because this is what actually sticks out of the ground. They're actually below that. Most of them that we have in DeSoto anyway are down at the valve that is in the ground. Okay, if the hydrant is not completely open or closed, the drain hole will be partially open and cause solid soil erosion around the hydrant base. Just talk about that. Alright, a wet barrel hydrant, that's the ones you'll see out in California, where areas that it don't freeze. Always fill with water to the compression valve at each outlet. That's why you'll see multiple attachment points for your hydrant wrenches to turn those on and off. You can turn specific ones on and off. Also referred to as fast free or California hydrants. That's why when you see in the movies or watching cops videos and they crash into their fire hydrants and the water shoots 50 feet in the air, because they have wet hydrants out there. Okay, NFPA 291 hydrant color coding. The light blue is a 1,500 gallon per minute or more. Green hydrant is 1,000 to 1,499 gallons per minute. Orange 500 to 999, and red is less than 500. There's also a black, which means the hydrant is out of service if it's painted black. Local color coding of hydrants differs depending on the jurisdiction. I know in DeSoto we adopted the 291, the NFPA standard, so we have all of ours color coded per NFPA standard, and it's just these right here. Some cities do not do the color coding, so a lot of the neighborhoods take it upon themselves and paint the hydrants whatever they feel like. For instance, we were up in St. Louis not too long ago, and up on the hill, most of their hydrants are painted in the Italian colors. Okay, we're going to the dry barrel hydrant operations. As a safety precaution, tighten hydrant outlet caps that will not be used. Turn the outlet cap nut counterclockwise and remove the outlet cap. If time permits, flush the hydrant before connecting any hose. I would say flush the hydrant regardless, because there could be rocks or with golf balls or anything else shoved in these things, and just to flush all that out and make sure you actually do have a working hydrant for one before you get everything connected and realize it's not working. I'm going to connect the hose. Stand on the opposite side of the opening discharge outlet. Turn operating nut in direction of arrow counterclockwise. Okay. Opening too fast may cause the hose attached to flail violently or burst, and closing too fast can cause a sudden increase in water pressure within the water system, causing a water hammer. Okay, if water is bubbling up out of the ground at a dry hydrant's base when the hydrant is fully open, a broken component in the hydrant barrel is allowing water to get past the drain opening. After use, test the ability of the hydrant to drain. After flowing water, close the hydrant and cap all discharges except for one. Place your hand over the opening discharge and you should feel a slight vacuum as the water is draining out. Hydrant effectiveness may be affected by different factors. Obstruction erected too near a hydrant, such as signs, poles, fences, may limit your access. I've seen even utility poles placed too close. Discharge outlets may face the wrong direction. Hydrants may be damaged by traffic or vandalism. Corrosion may prevent the proper operation or impede the flow of water. Lack of clearance between outlet caps and the ground. The hydrant there is pretty much useless. Outlet caps missing or stuck in place with paint. Stem nut that cannot be turned or turns freely with no results. Obstruction, bottles, cans, rocks inside the hydrant outlets, so you always flush the hydrant. A damp ground, erosion around a hydrant indicating a leak, and hydrants improperly painted by property owners. Alternative water supply may be used even in the areas with adequate water supply. The water system may fail due to broken mains or power outages. Fires may occur in areas some distance from hydrants, such as fields or along limited access highways, and departments may have to draw water from sources such as lakes, ponds, rivers, swimming pools, and water tenders. Drawing water from a static source to supply a pumper is also known as drafting. Hard suction intake hose is used primarily to draft water because it is designed to withstand the partial vacuum created when drafting without collapse. Drafting operations are affected by debris, sediment, and rocks, which can clog strainers, damage pumps, and clog nozzles. Hard suction hoses must have strainers in place when drafting from a natural source. Strainers may be supported by a ladder or floating strainers used to prevent hose from drawing in sediment. A strainer should have at least 24 inches of water above or below it. Floating strainers can draft from water as shallow as 24 inches deep. In some areas, dry hydrants are installed at static water source to supply water for firefighting. These dry hydrants are usually constructed of steel or PVC pipe with strainers at the water source and large connections to connect the pumper to. In order to establish a water supply from a dry hydrant, hard suction must be used in a drafting operation setup. Get into drafting operations. Suitable water source must be located for adequate water supply to allow positioning of pumper nearby. Pumper is positioned near a water source. Check hard suction couplings for dirt, debris, and worn gaskets. The hard suction hose is attached to intake on the pumper. A strainer or floating strainer is attached to the hard suction. All connections must be airtight to allow for adequate draft. If a floating strainer is not used, a ladder should be positioned in the water for the strainer to rest on. strainer is then placed in the water. Pumper pulls a draft by priming the pump until positive pressure is indicated. If you're unable to achieve a draft, tighten connections with a rubber mallet. If still unable to draft, lift may be too great for the pumper to overcome. Rural operations usually consist of water shuttle operations. Water is hauled from a supply by water tenders or tankers to portable tanks where it can be drawn for the tack pumpers. Water shuttles are recommended for distances of 1.5 miles or greater than the amount of supply line carried. Enough water tenders must be available to maintain the needed fire flow. To be successful, fast fill and fast dump times are required. Water supply officers should be at both the fill site and dump site. Personnel should be assigned to traffic control, fill site connections, and dumping. If possible, tanker drivers should stay with their vehicles during this operation. Water shuttle operation components. You'll need a water source or fill site, transport system, tanker or your tender, and a dump site. Pumper drafting from tanks to either supply attack lines or supply another pumper used for fire attack. Water shuttle operation components. You have portable tanks ranging from 1,000 gallons and up, may be collapsible or folding with a metal frame holding a synthetic or canvas duct liner. May be self-supporting synthetic tank with a floating collar that rises as the tank fills. Before opening a portable tank, a heavy tarp should be spread on the ground to protect the tank liner from damage. If possible, portable tanks should be positioned as level as possible to allow for maximum capacity, to allow for easy access for tankers from multiple directions, so as not to obstruct scene access from other apparatus, and with the drain towards the lower side. Low-level strainers may be used to get the most water from the portable tanks. If multiple tanks are used, a jet siphon can be used to transfer water between tanks. The jet siphon may be incorporated into a low-level strainer and attached to the hard suction hose which is placed between the tanks. A jet siphon draws the water through the hard suction hose and into the other tanks. Water tender or tankers, these are covered under an NFPA 1901 standard for automotive fire apparatus, and they require that water tenders on ground level be capable of dumping or filling rates of at least 1,000 gallons a minute. Pumping water tender unloading methods, gravity dumping through large 10 to 12 inch dump valves, jet dumps that increase the flow rate, apparatus mounted pumps that offload water, and any combination of these methods. Water tankers must be capable of being quickly refilled during emergency operations by using the best fill site or hydrant available. Large hose lines, multiple hose lines, if necessary, a pumper with adequate flow. Relay pumping operations. Multiple pumpers can be used in a series to relay water to the scene if the water source is not close enough. The water supply may be capable of maintaining the required volume for the incident's duration. The number of pumpers needed will depend on the volume of water needed, the distance from the water source to the scene, the amount of hose available, and the pumper capacities. The pumper with the largest pump capacity should be located at the water source. A relay pumping operation must be established quickly to be worth the while, the time and effort to set it all up. Water supply summary. For as long as there has been firefighters, water has been the primary tool to control the fires. Firefighters must understand how water systems function to provide them with the water needed. And more importantly, fire personnel must be proficient at getting the water from the supply source to the fire apparatus and then on the fire.